As you are listening and watching at me in front of a computer, I presume that you are sitting inside a building, probably your home or your work. In the most extreme case, it can be snowing outside or raining, or perhaps it's too hot or too noisy. But I presume, again, you sit quite comfortable and safe. And even if outside the conditions could not be so nice to follow a MOOC, you do not expect the house to collapse. Everything is working inside, and you are quite concentrated with what I am saying. Or at least, it is that way it should be, isn't it? Yes, it is a bit weird to start talking about houses when we should discuss about software, but I am doing it on purpose. Usually, houses are systems that must be built following a proper and well-documented process, and the construction, once it has been created, must include all the properties of a building and must be safe. Even more, before a human can use it, the house must be certified as safe. Because, for example, you would not like to live in a house that can collapse when it gets wet, or where the walls fall down when you hang a picture, isn't it? And it could happen if, for example, we construct the walls of a normal house using a light material, like cardboard. Yes, in industry, as in software, before building a system, it is necessary to understand why you must build it, and it is also necessary to clearly specify what must be built, how it is going to be built, who will build what, and when it will be built. Do you know why? Because otherwise, nobody will be able to answer the most important question about building things. How much is it going to cost me? Let us suppose that I want to build a brand new house, specially designed for me and for my family needs and interests, and you, such a coincidence, are a building constructor. Considering what we have been discussing in this video, it wouldn't be good news for me if the first thing you do after we have agreed to build my new house is just start digging a hole in the ground. Roughly, the first thing to do when you and me have agreed to build my house is talk, and talk, and talk, and talk, and talk, and take notes, and check the notes, take more notes, check those notes, and do this again and again. And carry on until... What do you think? When should you start doing something different and interacting with the relevant stakeholders and taking your notes? You can pause the video if you want to think a longer time. Yes, you're right. We should not stop interacting and exchanging information until you, the responsible person for the construction of the building, completely understand what I want. And I, the customer, completely agree with what you have understood I want. Easy, right? In theory, yes, I hear you. But you want me to repeat. These principles are exactly the same for whatever system development you have to face. An airplane, a camera, or a medicine. And of course, it applies even with more strength to the development of software systems. There's only one case in engineering where this principle is not applicable. When the customer does not properly know what he or she wants. Of course, if I don't know what I want, you will not be able to properly understand it, and neither represent it. Even if it's possible to build these kind of systems, I personally would not like to be one of their users, particularly if they have to deal with my safety. So, to sum up, the customer has needs, and the engineer would like to transform and represent those needs as requirements for the new product to be built. Requirements come up to the scene, and the impact of their existence is certainly large. In the next section, we will give the previous principles a proper name within software engineering. Even if this previous introduction has been perhaps a bit weird, we should now be ready to start. Let's do it. When the decision about building a particular system is taken, the budget and the effort have been allocated, the first thing to do is to understand the customer needs about the system. And your responsibility as a software architect must be to clearly describe the customers' and other stakeholders' needs using requirements. Requirements engineering is the first conceptual tool the engineer must use to do the right thing. Let me show you a lovely cartoon that describes why we need to think about requirements. Nice, isn't it? This cartoon represents the notion that when you have to build a system, it is necessary to consider all different points of view from all different affected parts. As we have said before, this practice must be done using requirements engineering. Let's also conclude this video answering the question stated in the title. How can you be sure that you know what I want? You will be sure when the following process has successfully occurred. First, you have gathered a set of requirements that clearly describe all my needs. Second, you have verified that the requirements are written in a correct, consistent, and complete way. And third, I have validated those requirements, agreeing that they describe my needs and restrict. And a fourth one, talking engineering language. The engineer has produced a requirement specification that has been internally verified by your team and validated by the customer, me. Once this has happened, we would be ready to design our system. The mission of the next video will be to explain you what to do in order to produce a requirement specification. Goodbye.